One more part of virtual functions. There is a possibility to declare a virtual function to be a pure virtual function. So how is this done? Let's use an example of this. Basically, we could have decided that we want not to use print at the base level at all. I don't think it's a good idea in what we have, but just to demonstrate the syntax, I'll show you what the syntax is going to look like if I make this change. So instead of calling customer print, so now what I'd like to do, I will make this print function pure virtual function. I will explain to you in a second what this is, right? So this syntax, that something like this equals 0 with a semicolon, this is still a declaration of a function, and it's now a pure virtual function. And this will be no longer a virtual function, but something called print base customer, something like this. And so this will change to print base customer. Okay, so print the base portion of the customer. Okay, so what is going to happen is that at this stage, let's also move this to the side, and I will try building this. Okay, so unfortunately, the possibility of instantiating a customer is no longer possible, because pure virtual function suggests that this class is abstract. What does it mean? Abstract class means that this class is unfinished. It's intentionally designed to serve as a base class for some other derived classes. And the print functionality here is intentionally unfinished, okay, intentionally left undefined. It's declared so that we can implement our virtual function calls through this declaration. But the customer level of print is intentionally left out. And it has to be done at every level where the new derived class wants to derive from this base, abstract base class, and now it must provide this. So what it makes compiler do, that the compiler says that you can no longer create objects of abstract class. So now this has become abstract class because it has this piece right here. Okay, so what do we need to change? Well, I guess I can just, like, what chances do I have? I'll just replace these things with strings and numbers, just hard coded like this, and avoid creating a customer. All right, so where else? Company 2, so I'll just use this number right here, and this string right here, so I'll just replace it like this. So I just populate these, and customer 3, very good, customer 3 here, and this. Okay, so in this way I'll get rid of creation of these customers because I intentionally make them pure. Okay, so not much is going to really change if I build. Okay, if I build this, it still builds the same way. I run it, it works exactly the same way. If you compare it with the previous version, all individual classes get printed appropriately. The virtual function works as expected. Everything is working. Okay, except that by design, we could decide that at the base level, we may want to prevent any definition of our interface operation print, and to tell the compiler that we intentionally want to keep this declaration only a declaration, and that's the designation of a pure virtual function. So the requirement is that any derived class like this or like this has to provide the concrete real definition of this function. And you see that now it works fine. So this is a version which uses a pure virtual function print. Under the covers, we already described the idea of vtable pointer, and we have observed the little changes that were taking place, going from non-virtual print to virtual print, and likewise in 64 build type from 48 to 56 bytes in this situation, right? So this just gives you a set of hints how virtualization can be implemented by your compiler. It's really up to your compiler how to do this, but this is pretty much almost like, you know, the most direct way of doing it. So virtual table existence and pointer in a hidden object to the virtual table. And finally, the importance of a virtual destructor. Okay, I'd like to start with basically the last line on the slide. Any class with a virtual function should certainly have a virtual destructor. Just like this, right? So we can, like, after defining our constructors, we need to add a virtual destructor, just like this. And it does nothing, but it has to be declared virtual. Okay, so just like this. So I just want you to remember, as soon as you've placed this virtual keyword somewhere in your class hierarchy, remember that here, this destructor, only this destructor right here at this level where we start using virtual functions, must be present here, because otherwise, again, going back to the top of this, the reason for this is that destruction of derived objects such as this and this, right? And let me just move this to a previous tab like this and resize it. All right, so the destruction of derived classes like company and person that derive from customer through the base reference or pointer, okay, will be undefined. In other words, if we create these objects dynamically, if we create company and person objects dynamically using the new keyword, and then we would like to deallocate them by using the delete keyword, removal, freeing the memory, may not work properly, and that's very, very dangerous. So just remember this rule. It's just really the bottom line is this, and this is absolutely important. Almost like the first time we added this virtual keyword, we tried to make it work. It worked. The next step for you is this. Just make sure that you add destructor for your class. You may not have to do much, but you have to have it. Okay, so it's just this simple and this strange. Unfortunately, there is no warning from the compiler. There is no any kind of explicit indication that this could be a pitfall or trap or something that could cause bugs and nasty memory allocation, deallocation problems. But just remember, if you have any of these issues, just make sure that at some point when you design your software, just revisit your class hierarchy using virtual functions and make sure that somewhere as soon as this keyword appears, you add a virtual destructor. This is it. I would like to conclude this as a summary to our presentation on the hierarchy of objects or classes or structures, and we concluded with this very important rule regarding a virtual destructor addition to the top of your hierarchy where the virtual functions begin to originate. Now, of course, we have more slides on this list, but I would encourage you to continue reading the handout. It's just a series of tips and examples, but I only would like to focus on this part where we stop this series of videos at this point where we describe the behavior of virtual functions and the importance of the virtual destructor in your class definition.